I'm Gordon Klok. I'll be giving the talk this morning. Dimitro's in Berlin, and Roman just had his firstborn, so they unfortunately couldn't make it. We are the founders of Pax Automo. This is a new startup we're doing this year. The bulk of this presentation actually comes out of a question. You know, when you first do a startup, you have to do, you're supposed to do, well, there's all these wonderful books on, product research and market research and things of that nature. And this question actually came out of our trying to do that exercise for our little venture. So the question that we were trying to answer was this, one of the economics of, when does it actually make sense to build your own infrastructure? It's pretty crazy nowadays, right? Like, when I was a kid, having exclusive access to a computer, it's nuts, right? Now you can plunk down your credit card and, spin up 100 or whatever the API limit is on Amazon for your given account or whatever, and then you just email the salesperson or whatever. So it's definitely much easier to provision very large computer systems, but there's still an ecosystem of, build it yourself, order things, and there's various things in between, right? Of course, you can, there's contracting companies you can call up, and they'll actually put all the physical infrastructure for you together. You're just responsible for the software stack. So the question then becomes, well, when does it actually make sense to do this? Because of course, we all know there's quite a lot of hassle. You've got to, order the computers, which is a big upfront expense, and you got to put them somewhere, power them, and then you have to actually take care of the software stack. So obviously, that's more than just spin up the instance on Amazon. This is I don't know if we almost didn't include this slide because especially in the smaller sort of DevOps community, tends to be, okay, just do it in the cloud. No one wants to change SSDs. What is this crazy stuff, right? And within, larger organizations, it's like a tenet for a civil war almost between some departments or whatever, especially if you still have that dev versus ops split. It really shouldn't come down to that. I mean, there's the thing about what we're talking about is this economics problem is that it is really just about, what the cost of the CPU cycles you're using is and the memory and interconnect. I mean, you might have other organizational priorities that makes you favor one choice over another, but if you want to get right down to it, it is really about that. This is not a new problem. There's sort of kind of two things that we, talk about. So we talk about utilization of the resources, which is, how you're actually using the computers or instances that you're buying. But related to the cost is obviously your ability to forecast that. There's a duality between those two things where if you can't forecast out into the future, you need to buy more than you're going to use, and then your utilization is going to be lower, right? So please think of the polar bears. It's not just economics or whatever, right? I believe the figure is 1% of all electricity used in the world is being used by data centers, and it's one of the fastest consumers of it. We'll see with electric cars whether that holds true, but it is definitely a big deal. So the utilization of computers, this part applies whether or not you're considering building your own infrastructure or you're using Amazon instances. I've heard it referred to as the bin packing problem, which is how do you get more of your individual processes that make your application onto the same instances. There's, obviously you can save some money that way or whatever, but even in the cloud, it actually does make sense sometimes because you tend to, with the fatter instances, get more bandwidth and you're not necessarily dealing with your noisy neighbors or whatever. In the kind of data center space or your own infrastructure or whatever, we've tried to solve this problem in the mid-2000s. It actually is the technology that gave the public cloud or utility computing its future or whatever, right? Was the kind of virtualization or whatever. And in retrospect, thanks to containers starting to become prevalent and stuff like that, it's actually kind of a crazy solution to kind of an insane little problem silly problem that we made for ourselves, right? Since it's mostly about resource isolation, which the C groups takes care of, and the namespace isolation, which is another thing from the containers. Like we ended up virtualizing Linux on Linux, and it's like, why, right? This is my conjecture. It's better to actually work on fixing the packaging in your deployment, like the orchestration. Use Kubernetes or Mesos or whatever to actually schedule your processes on those machines. Try to get to fatter instances and things like that before you worry about whether you're going to build a data center or kit out a colo area or whatever the problem might be. The other thing is, I mentioned this duality of, if you have really low utilization, if you can't predict your future, and effectively deciding to do a colo or to build the data center is an investment decision. It can be fairly substantial, right? It's best not to go into that blind. So if you're like in your very early phase of a startup, say, you're going to have it's going to be very difficult for you to actually predict your resources, but as you, like how much resources you'll actually need for your application. As you get a little bit more mature, and definitely as the scale goes up or whatever, it becomes much easier to actually predict what your demand is going to be. So the metrics that you need for it, and that's actually the metrics of just operating computers. They're covered in the systems performance book from Brendan Gregg, so check that out or whatever. It's like CPU cycles, CPU time, memory utilization, that sort of thing. You should be able to answer those questions about your service anyway. It's kind of like, I used to tell interns that one of the red flags for whether or not you should stay at a job is that if you show up on day one, they hand you the source code as a zip file, or worse, tell you to log into the server and edit the files on the server. You should probably just ditch that internship, go somewhere else. Similarly, if you show up at a place and it's operating an online service and they have stated SLOs or SLAs and they're not actually measuring how much requests they're getting and how much CPU time is being used, it's probably a red flag for a long night. So the thing is too with capacity planning is that it's very much like an academic discipline. There's fancy papers and all sorts of things about that. Dimitro, and that's actually what Dimitro does for his career. He suggests the art of capacity planning, which actually is not that. It's quite a bit more straightforward or whatever. It advocates you can probably just take shorter or like fairly simple things that you can do with Excel, like plot trend line or whatever, and use that to actually do your forecasting if you're not at the stage where you're going to be able to do more complicated things. So. There we go. So yeah, there is definitely a scale component to this as well, and that's mostly driven by your investment decision, like your horizon for how much you invest. Obviously, if you only need 2 instances or whatever, Amazon is definitely going to be the place for you. Once you start getting up there or whatever, it might make sense to start building the infrastructure. That's the question that we asked, was when that crossover point is. And of course, yeah, I mean, you're probably not. You probably have like an entire team working on this. If you're in I'm gonna go buy some land in Oregon and build an entire data center or whatever. That's basically $1 billion investment, right? So we're mostly focused on the first two, that transition from the like public cloud to data centers, or perhaps you're in data centers and you're like, okay, I'm looking for a reason why we should be in the public cloud. This is not a very straightforward problem to answer. I mean, you can just go, okay, we're gonna get this many cores in Amazon and this many cores in a data center and go, but it actually that's a very simplistic way of doing it, and it's going to lead to like somewhat strange outcome, right? Because I mean, we're supposed to be rational economic actors. It's the basis of our whole economy and all that wonderful stuff. not really well supported by any actual measurements. But anyway, we have this idea that we should be able to do this. That duality of if you can't know your future, then you have to over-provision. So when we were actually putting together this model of it, it's not enough to just go, okay, well, we get this many cores from Amazon, we get this many cores from in a data center, and hey, there we go. Here's our model. We could do that. It's too simplistic, right? Because of course, the whole benefit of the public cloud is you only allocate what you need when you need it, right? And you have things like auto-scaling groups that will actually let you do this without manually planning the capacities. So it's not enough to take the simple model and just go one-for-one comparison. You need to be a little bit more sophisticated than that. So what we looked at was, what's the effect of, we assume that you're gonna, to get the maximum discount from Amazon, you're gonna buy reserved instances for what you call your base load, or what we call the base load, which would be, if your service is, like, say, human-driven, as many things are, you have operate a web page or video games or whatever, right? Where the sun's moving across the earth actually determines, how much API traffic you're going to get, or whatever it might be for that day. And it's different. There's obviously other things. If you have an IoT model, then that's going to be a different demand pattern. You really need to understand that. For the purposes of the model we built to do this cost comparison, we chose to look at it from it's like a user, it's an online service for users that are going to have, varying demand within the day. You're going to use auto-scaling groups to scale that demand up and down to meet the need. You're also going to, though, have a base load. You're going to try and maximize minimize your costs on Amazon by buying reserved instances so that you're satisfying that. And then, of course, for the data center, you have to. We chose to do so. This model is actually fairly unfavorable to the data center. We chose to set the max utilization for the period of time at 30%, which is fairly low. We're only assuming you're actually running the online application, and then you're not backfilling your clusters with anything else. That's kind of an unrealistic assumption. I mean, if you're paying for the computers, you're probably going to try to use them as much as possible. Because of you can't just ask the Amazon API for more CPUs if you're operating in the data center. You have to. There's lead time. It could be weeks, it could be months. If you're building, billion-dollar data centers, it's definitely years. So you have to over-provision, and you pay those costs regardless of the growth in your API or whatever. So we chose to use 3-to-1 ratio. Dimitro's main remark on this is you can get this down. Especially as your service becomes more popular, your demand tends to become more stable, like law of large numbers or whatever. So it becomes easier to actually do to be more confident in your forecast, and then therefore not have to overbuy. So we were assuming the AWS M2 2x large instance, 100 gig volume with 750 provision IOPS. We're assuming you're going to back up your volumes on EBS to S3. We are not assuming that you're operating with a failover site, whether that's a different availability zone or that. It was quite a debate between myself and Dimitro, but whether or not that was a good idea to not include it. And then the S3 outage happened, and like a ton of stuff broke, and it became clear that it's like not an industry practice anyway. I joke a bit, but I mean, failover is actually not an option. You can't really guarantee this at the infrastructure level. This isn't to talk about reliability engineering, so I won't get into that in detail, but generally speaking, the app needs to do that, or the way that you route your users to your application. That's where that's going to happen. There's no magic infrastructure that's going to stay up 100% of the time. It's just going to work, right? So for the colo space, so again, we're assuming cages, you're in a purchase gear or lease gear. We wanted to make sure that the CPU memory and storage capacities are the same. We're assuming you're using some sort of distributed block store, whether that's, we think in terms of Ceph, but there's other options as well. And you're going to have 3 times redundancy in that. And because we don't have a S3 to, well, sorry, Ceph does offer a S3 gateway, but you probably don't want to back up Ceph to itself, right? Doesn't really make much sense. We have to toss a backup server into the model architecture as well. Okay. So because of that initial investment and your monthly reoccurring costs, up until you start getting into the hundreds of these M4X large instances, it's definitely cheaper to be in Amazon. So that's and $100,000 a month is beyond. I mean, I'm sure a lot of startups in the room are, that's crazy. Who would spend that much? It does happen though. So. And so that's the monthly recurring cost. And the crossover point is, okay. So the crossover point is, yeah, it's about 150 instances is when it really starts to make sense to be looking at, colo with again with the assumptions that we've built into our model. When we break down where the costs are and okay. This is not a shock to anybody who's actually done stuff in the data center space or worked with them before. The main cost is people. So what we actually did in the model, the model is fairly complete. It actually took Dimitro probably about like a week, basically 45 hours to build. We take into account all the crazy little costs that PDUs and cabling and all that stuff. We also added $500K per year for the additional operational expense of that or whatever. We were figuring 2 people at $250, but I mean the thing is you can break that down a lot of ways or whatever. You're probably not going to have somebody visit on site all the time or whatever, so you might use remote hands. That budget, I mean, we basically just allocated $500K per year for this. So that's actually a big chunk of, obviously, of it or whatever. The next big thing is the chassis cost. Generally speaking, bandwidth is much cheaper if you're operating in a colo than it is in Amazon. And the other part of it is I don't know actually know where Dimitro was pricing the electricity, but that actually plays a huge role. If you're going to try and kit this out in Japan, for instance, it's going to cost you a fortune. Like Oregon or Georgia or something like that might be significantly cheaper. So when we look at the AWS costs, the compute is a lot more expensive. Again, this is where you're able to predict a certain base load that you're able to buy as reserved instances, but you can't obviously do that for all of it or whatever, or if you can, then you can make that significantly cheaper. The storage costs are mostly for the provisioned IOPS. I know there's ways to cheat by having bigger volumes and you get more that way or whatever. But if you have SLOs and latency penalties, that might not necessarily fly, right? So if you do decide to actually build this infrastructure in your in a colo or something like that, a lot of the attention in the DevOps community and elsewhere has been on the cloud because that's enabling a lot fewer people, these DevOps teams to do a lot more with with less people, which is great, right? But the hardware space hasn't stayed frozen, right? A lot of stuff has actually changed in a while or whatever. So Paul and I, we worked at U of A. We did consulting for like high performance computing, and it's the sort of the modern way of designing hardware is like what was in the HPC space 10 years ago, which is a lot of it is to do with the networking. It's the foundation upon which you build everything. So if you screw that up, you're going to have a really bad time in your colo. Or your data center, and that's probably the reason most of us have had it. So it's software defined, like for everything. If you have a really big problem, if it's like your deployment plan is, open a ticket with Team Foo or whatever to actually get the external service provision, you spend a bunch of time for no reason. The other big thing is that the big thing with so there's a right amplification factor. Even if you have an e-commerce site or whatever, you have your fairly simple, straightforward shopping cart, but then you're going to make recommendations about other things to buy, and you're going to have all these things. You can hopefully deploy those as microservices, or even if you're doing a monolith, you have one incoming request. The GET request is relatively small. All of a sudden, you're in your backend in the cluster. You're making dozens or hundreds or even thousands of requests to other services within that or whatever. The bisectional bandwidth, it's sometimes referred to as east-west. Like you have a process on this node here, and you want to talk to the process on maybe 3 racks, process running on a CPU maybe 3 racks over or whatever. The bandwidth by which they can talk dictates the performance of your application or whatever. So if that's a MySQL database, for instance, your query. So that bisectional bandwidth across the network is really important. Most old enterprise networks had this, they had a lot of switchback planes in them, and the switchback planes are not really rated for the line speed of the. So you plug it in 10 gigabit, but it's like 1/72th of that between given nodes depending on the topology. So there's cross networking. I'm gonna go faster. The other thing is, avoid complicated networking like VLANs and stuff like that as far as within the cluster. Use flat addressing space. Most of the enterprise value add stuff, it's just bugs. You honestly, can you power cycle it? Does it boot off the network good enough, right? Like, if you have something horribly wrong if you're spending all your time on some sort of weird keyboard video mouse console thing. The other big thing is lifecycle management of the hardware. If you're going to buy this, make sure you're not buying like, oh yeah, this week we ordered this model, next week we ordered that model or whatever. You're buying something for 3 to 5 years. Spares will become a problem at some point, and if everything is different, for instance, this becomes kind of a huge pain. So this is a Klok network or whatever. Cumulus Networks actually has some great stuff on their website, which you can go check out, including, I believe they have the GNS3. They have instructions for, there's something called GNU Network Simulator. You can go download that. You can actually set up a Klok fabric in, using GNS3 and some VMs that you can spin up, and then actually make sure that your network actually works. Another option, if you don't want to go Klok, or it's ultimately a similar architecture, but InfiniBand, the per port cost is actually fairly low, so something to look at. For our racks, now it's going ahead. We have, for the Klok network, we chose these 2 models of, I'm not going to say the vendors because it's not pitch. There's 2 models of there's 2 spine switches for 5 racks. The top of the rack switch is actually the leaf switch. So these are crazy switches. Each one of those ports is 40 gigabits per second for the spine switch, which you can split 4 ways. The switch is less than 10 grand. I mean, the cost for most of your cost is going to be in the, I think they're QSFP plus, the actual physical connector in your cabling. And the switches all just run Linux. So you can automate them with Ansible or even Puppet if you're a masochist or whatever, right? Like, so we use these servers. We did actually build into the model like the power consumption. We kept the per rack at like 20 kilowatts, which should fit into the power envelope of most colo providers. And then for the backup server, this is nuts. This is like 90 disks, I think, for you. It's a petabyte, basically per rack. It's madness, right? I'm also not saying the vendor, but you can probably figure it out. Our conclusions, though, from looking at this was basically don't rely on axiomatic beliefs about infrastructure. Your infrastructure costs are approaching 100K per month. You're probably going to see significant benefits from doing the colo thing yourself. And if you can't forecast your demand, this makes no sense. Don't figure out your demand, right? All right. If you have any questions, you can email us. But I think we're basically out of time. Sure. Sorry, we're going to actually put this. So Dimitri developed the spreadsheet. There's lots of cursing about Google spreadsheets. We're actually going to make the spreadsheet available so people can copy it and clone it and put their own scenarios into it or whatever. This is going to happen next week when Dimitri's back from Berlin. So if you want, you can also, I think we have a Twitter account. I'm not a Twitter user, but we have a Twitter account. You can probably follow that, and we'll actually post a link to that when it's up. So thanks. Is it okay?
Does anyone have a question?
Sure.
I had a two-part question. You probably answered the first part, but wasn't listening. In your Colo graph, where by the end of your graph, AWS is twice as expensive.
Yes.
Were you calculating for the extra hands you're hiring in the Colo provision your VES?
Yeah, so we did actually mention that we put a $500K budget in for that. That's good that you mentioned that part. There was one caveat with that. At some point, your spine cost for the switches becomes too expensive. It's like 5,000 instances or whatever. And at that point, Amazon, I should have, sorry, that's big miss or whatever. That graph continues, but that's just one snapshot of if you make the graph longer, it'll obviously, at some point, that particular network architecture needs to be substituted for another one. It's going to cost more money, right? So, your second part?
The second part was just also scaling the people that you're hiring. If you're dealing with 1,000 to 2,000
So your question was about scaling the people that you're hiring or whatever. It wasn't really in the purview of the talk, but of course, that's kind of an organizational HR challenge for everybody. Even finding the people is probably pretty difficult now. Hyperscalers tend to hire everybody. But the thing is, if you do the sort of modern architecture thing correctly, you're not going to need people on site as often because you don't care if the drive failed because it's replicating Ceph 3 times. Somewhere else will pick it up when it fails and stuff like that. The hardware, you could have bad run of somewhat. There was a hard drive manufacturer somewhat famously had like a 30% failure rate or whatever. I think you can read about it on the Backblaze blog. So that could be a disastrous scenario for this or whatever, where your cost on site could get out of hand or whatever. So yeah, I'm not an HR professional, so I don't know what how to scale the teams for that or whatever. I think the cost though is that $500K. It's probably in the right thing up to like 10 racks, which is a lot of compute actually. There's one. So we put it at 2. It's 250K. Oh, sorry. You were asking. We put 500K per year for headcount, and what does that break down to? So we put it down for 2 people in our model, or that's what we were thinking would be that 250K per year is pretty high for even in Silicon Valley. That would be fairly generous. We were figuring you would need one person with an expertise in software-defined networking, and that. We were assuming that your existing DevOps team would be amenable to, also doing the deployments on this. So if they're familiar with setting up Kubernetes in the cloud, they can almost certainly get it working on this architecture or whatever. And then the other bit of it would be the actual physical management stuff, whether you're paying a value-added integrator when you buy your hardware to actually do all the cabling, drop it on site, and do all the repairs, which is an option, and would fit within that 250K a year, I'm assuming. Or you're, every once in a while you're flying somebody on site to do the warranty or whatever, that kind of thing. So, thanks.
Wait. Thank you very much, Gordon.